Hello, my name is Matthias, and I'll be presenting EQ Prereq 3, Minimum Acoustic Performance. It should be noted that this prereq only applies to school projects. The intent of the prereq is to provide classrooms that facilitate teacher-to-student and student-to-student communication through effective acoustic design. Acoustic performance is important to consider when designing classrooms because it can affect students' learning. Background noises compete with the primary sound source, and reverberation reduces speech clarity. Students of any age who are distracted by the extraneous sounds have difficulty retaining information and staying engaged in learning. For children with temporary or permanent hearing loss or cochlear implants, and children who are non-native speakers, poor acoustics and students erect needless additional educational barriers. Here are some important terms and definitions. I recommend pausing the video to read them over before continuing. There are 3 requirements for this prereq. The first is HVAC background noise. There should be a maximum background noise of 48 A-weighted decibels from HVAC systems in classrooms and core learning spaces. The second is exterior noise. For high noise sites where the peak hour LEQ is greater than 60 A-weighted decibels during school hours, implement measures to minimize noise intrusion from external sources and control sound transmissions between classrooms and other core learning spaces. For reverberation time, adhere to the upcoming requirements. There are 2 options for completion of this prerequisite. In option 1, for each room, confirm that the total surface area of acoustic wall panels, ceiling finishes, and other sound-absorbent finishes equals or exceeds the total ceiling area of the room. For option 2, confirm through calculations described in the ANSI Standard SI2.60-2010 that rooms are designed to meet reverberation time requirements as specified. There are 10 steps that you need to take in order to complete EQ Prereq 3, as you can see here, and we'll be going through all of these in much greater detail later, as well as any possible path deviations. The first step is to identify all classrooms and other core learning spaces, using the definitions given in the lead manual. Step 2. Review acoustic criteria. Evaluate how the 3 acoustic performance areas addressed by this prerequisite affect each applicable space. Be prepared to keep a log or spreadsheet to record the pertinent acoustic information for each space. Determine how the acoustic requirements fit into the design process so that each can be addressed by the responsible party at the appropriate time. Step 3 is to address the HVAC background noise. Identify equipment and air distribution elements that can contribute to HVAC background noise in core learning spaces. Compile acoustic performance data at the specified operating points from the HVAC equipment manufacturer's data. Be sure to consider source receiver paths when locating core learning spaces and HVAC equipment. Step 4. Verify HVAC background noise. Determine A-weighted sound pressure levels for each core learning space through one or more of the following methods. Only include weight due to HVAC systems where applicable. Note that any table values greater than 40 A-weighted decibels are capped at 40 instead for the sake of this prerequisite. At the end, prepare a narrative that describes the methods followed and a summary report with measurements or calculations performed. Step 5. Determine presence of exterior noise sources. Assess the project site for exterior noise sources, either through a site visit during the normal school hours or through predicted noise sources. The second part of the step is to identify significant noise sources within half mile or 100 meters of the face of the building. Examples of significant noise sources could be a concert venue, sports venue, a rail track, an airport, or an industrial plant. If the site is in the flyover area of an airport, L sub DN data is typically available online in noise exposure maps. If there are no significant noise sources, skip the exterior LEQ measurements and skip step 6. Finally, conduct acoustic readings on the project site that measures LEQ in dBA. Measure exterior noise during the normal period of school hours and repeat as necessary to capture intermittent noise sources such as train and airplane traffic. Record your site observations, noting the source direction and intensity of exterior noise, so that the project team may develop design strategies for noise mitigation. If applicable, data from the NEM may be used in lieu of taking measurements. If the peak hour LEQ is greater than 60 dBA, the site is considered high noise. If the peak hour LEQ is less than 60 dBA, you may skip step 6. Step 6 is exclusively for high noise sites, and is to implement measures to minimize exterior noise intrusions. Minimize the amount of exterior noise in core learning spaces through several processes, such as collaboration through the noise generating property if it is possible, or defining the paths of noise on the site, and identifying how each measure implemented acts as a noise barrier or a dampener. Strategies such as site barriers, architectural material barriers, and construction best practices also exist. Step 7 is design for optimum and reverberation times. Use a sound absorptive material or other strategies to limit reverberation times in core learning spaces. Sound absorption materials may be applied to any planar surface in the space. Retreating walls is often the most effective, and sound absorptive ceilings are often the most cost effective. Refer to ANSI 12.60-2010 Annex C for design guidance. Determine sound absorption properties with coefficients set at 50 Hz, 1000 Hz, and 2000 Hz, and or noise reduction coefficients for absorbed materials. Use the manufacturer's documents or Table 1 in the upcoming slide for common materials. Step 8. Calculate room volume. Determine the room volume for each core learning space in the project. Use the room volume to determine whether the reverberation time requirements are defined by the ANSI or NRC-CNRC standard. If the project is less than 20,000 cubic feet, proceed to Step 9. Determine the acoustic design approach option that is appropriate for each space. Option 1 is for simple spaces with regular shapes and parallel surfaces. Option 2 is for more complex spaces or for project teams that want a tailored solution to handle unique conditions. For spaces with a volume between 13,500 and 20,000 feet cubed, Option 2 is strongly encouraged. Although such spaces are eligible to demonstrate compliance using Option 1, consideration of NRCs alone may be insufficient if the space features irregular shapes and non-parallel surfaces. These configurations may need acoustic panels on both ceilings and walls to reduce reverberation. Option 1 is total compliant acoustic finish area exceeds the ceiling area. Calculate the total ceiling area for the core learning space, including diffusers, grills, and light fixtures. Include vertical and sloped ceiling elements in the ceiling area calculation. The total area of compliant sound absorption treatment must equal or exceed the total ceiling area calculated in the previous step. Sound absorbing treatments may be applied to the ceiling or wall, or may be free-hanging acoustic features. Collect manufacturer's documents to verify that the NRC of each acoustic finish is 0.7 or higher. Record the area of each acoustic finish material for credit documentation. Option 2, ANSI Standard S12.60/2010 Compliance. Follow the procedures described in Annex 8.4 to confirm the reverberation times for each space complies with the maximum permitted reverberation times in Table 1 of the standard. Reverberation time must be verified at 500, 1000, and 2000 Hz. Calculation and measurement options are available. Retain calculations or measurements for credit documentation. For detailed reverberation time calculations, please see EQ Credit Acoustic Performance for further explanation. Step 10. Confirm appropriate reverberation times for spaces 20,000 cubic feet and larger. Follow the procedures described in NRC/CNRC Construction Technology Update Number 50 Acoustical Design of Rooms for Speech 2002 to confirm that the reverberation time for each space complies with Figure 3 of standard. Reverberation times vary from approximately 0.45 seconds to 1.23 seconds based off the space volume, use, and type. Reverberation time must be verified at 500, 1000, 2000 Hz using calculations and measurements. Retain calculations and measurements logs for credit and documentation. For detailed reverberation time, all projects have the same required documentation as can be seen here.
Now, let's look into some important enhanced indoor air quality strategies. The type of buildings that this credit applies to can earn up to 2 credits depending on the number of requirements they fulfill. The intent behind this credit is to provide occupants comfort, well-being, and productivity by improving indoor air quality. There are various means to clean the indoor air of the pollutants brought in by the occupants. The strategies to provide indoor comfort can extend beyond the outdoor air requirements by installing entranceway systems, use of filtration media, increased ventilation, and monitoring strategies for ventilation systems. Each of these strategies is beneficial, but use of multiple is encouraged. These are a few star-marked definitions to understand the requirements of this credit better. There are 2 options to fulfill the requirements for this credit. The first option is the primary enhanced indoor air quality strategies, which consist of mechanically ventilated spaces, naturally ventilated spaces, and mixed mode systems. The option 2 for this requirement is the additional enhanced indoor air quality strategies. It consists of the same requirements as the option 1, but the only difference is only one of the strategies are required to be used to fulfill this requirement and to earn 1 credit point. Mechanically ventilated systems further consist of number 1, entryway systems. These need to be installed at least 10 feet long in the direction of travel to capture dirt. Please make note, for warehouses and distribution centers, entryway systems are not required at doors. However, a garage must be installed between adjacent office areas. And for healthcare centers, a pressurized entryway vestibule needs to be provided. The option 2 also consists of exterior contamination prevention, increased ventilation, carbon dioxide monitoring, additional source control and monitoring, and natural ventilation room by room calculations. All these strategies help towards designing of the project to minimize and control the entry of pollutants into the building. Here is a step-by-step guidance to achieve the intent of this credit. The first step is to identify how the project is ventilated, mechanically, naturally, or with a mixed-use approach. The second step is to choose which option to consider for the project. As learnt earlier, option 1 requires implementation of all strategies, whereas option 2 requires implementation of just one strategy to the ventilation systems. The table here shows what strategies are required and what are not for the two options. The final step is to comply with the appropriate strategy requirements. There are detailed step-by-step procedures for the strategies related to option 1. It requires us to identify spaces, determine the types of spaces, and finally understand and implement ways to maintain these spaces on a weekly basis. For example, the figure here shows different kinds of mats laid out near the entryways to eliminate the pollutants that are brought in by the occupants. These procedures also include inspection of HVAC equipments, resizing them and increasing the fan capacity, and finally replacing them before occupancy. We also need to review and confirm that the design follows appropriate mixed mode strategies to fulfill the requirement of this credit. The procedures for option 2 is to locate the outdoor air intakes and determine a modeling tool to filter this air of external pollutants. It is finally completed by 2 levels of screening procedures that indicates the amount of pollutants inside the space. Ideally, the concentration of pollutants must be below 2.5% of the allowable annual average. Here's a table showing the required documents to fulfill this credit. Do keep in mind that using energy efficient measures such as increased ventilation, demand control ventilation, and dedicated outdoor air systems, we can reduce the potential energy penalty. Thank you for watching this video. Hope this gave you the necessary insight about the indoor air quality LEED credit.